All right. For those who don't know me, my name is Corren McCoy. I'm a PhD student. I'm also an industry professional. So my topic, or relevance-based model for ranking cyber vulnerabilities, is directly related to the work that I'm doing.
So, Corrine, at the risk of breaking things, can you turn your video on? Because we can't see you. Okay, great. Thank you.
You see me? Okay, there we go. Okay, so I'm going to start with, an introduction to the topic, mainly because I know this isn't something that we normally are accustomed to studying in this research group. So essentially, the terminology that we're looking at here is the vulnerability lifecycle, which has to do with why cyber attacks happen. And this vulnerability lifecycle is really the framework that we're going to use to understand how vulnerabilities in systems and applications become points of entry for attackers, and really how we're going to appropriately defend against them. Now, software weaknesses on the left here, these lead to vulnerabilities which can be discovered by developers who created the code, by third parties who report the vulnerability to the developer, or in the worst case, by cyber adversaries, the bad guys. Now, once the vulnerability is discovered, then risk increases. At this point, cyber adversaries, they're likely to develop exploits to take advantage of the vulnerability in order to compromise target systems, which causes a cyber attack. Now, the recourse for software vendors is to create a patch or fix, which reduces or eliminates the risk associated with their original software weakness. Now, vulnerability databases consolidate information on disclosed vulnerabilities. Now, the National Vulnerability Database centralizes information about those vulnerabilities and makes it easier for organizations to see if they're affected. Now, this database currently has over 170,000 entries, and the Common Vulnerability Enumeration, or CVE ID, is another name for a vulnerability that's been disclosed or published in this database. Now, this chart shows you some vulnerabilities that were released on a certain date, and it really starts to talk about a trend, which is that in any given period of time, we'll see lots of new vulnerabilities introduced, which creates issues of attention for any types of cybersecurity analysis. Now, the NVD also gives us some insight into perhaps, say, the last 20 vulnerability IDs that were scored. Now, as we think about that volume of vulnerabilities that are released, teams don't really have the capacity to go in and do the analysis on every vulnerability to determine how quickly to analyze them. And even with a condensed list like this, if we were looking at it in order, the vulnerability that we really want to pay attention to, it could be really way down on the list. And we really want to make sure with this research that we're able to take that particular vulnerability that is of interest, that impacts the system that we're analyzing, and have it appear more towards the top, kind of like your Google search engine would. Now, the Common Vulnerability Scoring System is an open framework for communicating the characteristics and severity of software vulnerabilities. Now, the CVSS, it consists of 3 metric groups, the base group, the temporal group, and the environmental metrics. And the NVD provides the CVSS score for almost all known vulnerabilities. Now, 2 common uses of the CVSS score are really for calculating the severity, which is the high, medium, low, critical, but also being able to use as a factor for prioritization or remediation. Now, the base metric scores, they range from 0 to 10, which are then placed in those categories from least to most severe. And then these CVSS scores, we have to remember that they're generalized. They're really just a global score at a certain point in time. Now, the base scores, they can be modified. They can be modified by setting the temporal and the environmental metrics. Now, the temporal metrics, they really reflect changes in the vulnerability over its lifetime. And it reflects the current exploits as well as the availability of any remediating controls. And those would be your patches or vendor advisories. Now, the environmental metrics, they account for the aspects of the organization that might increase or decrease the net severity of a vulnerability. Now, the critical thing we have to remember with the temporal and the environmental metrics is that they are not included as a part of the base scoring that's in the NVD. Typically, if you want to personalize the score, an organization would have to go in of all the vulnerabilities that they decide to analyze, and they'd have to compute these scores independently, which is really the reason why this rarely happens. Now, for this research, we think that ranking vulnerability can be improved if we take more of a data-centric approach. Now, one thing we have to understand in terms of the threat with vulnerabilities is that, the vast majority of vulnerabilities are never exploited. So over the time period that we're collecting data from 2017 to 2021, you can see we have like tens of thousands of vulnerabilities that are released each year or published each year, but very few in the single digits are actually exploited. And so if you're trying to create a remediation strategy where you want to make sure that you don't leave a vulnerability unpatched because you think it's going to be exploited, you're really trying to hit a very, very small target. And that's what industry is currently doing today, trying to create these predictive patterns to understand which vulnerabilities are going to be exploited. But it's a very small approach. So what we are doing is basically taking that vulnerability lifecycle and really taking a close look at the data sources that inform each piece of the lifecycle. Now, data from the scans and the vulnerabilities database, that's just the starting point for the cyber intelligence that we need. Unless this intelligence really comes from this wide range of data sources, then we will risk not looking at the real emerging threats. And so what we want to do is to really integrate all of these authoritative data sources so they're more threat specific according to the organization and industry ranking policies. Now, these data sources in the lower portion, they relate to like the common software weaknesses, which are design flaws, products, the CVE IDs, that scoring mechanism for the vulnerabilities. MITRE ATT&CK is a framework which identifies how a threat group might weaponize a vulnerability. Think about someone trying to break into your home. Like what tactics would they use, what techniques? That's what MITRE ATT&CK provides for you. And then from the exploit side, we want to be able to correlate that with known exploits from a variety of sources, some are which from industry like Exploit DB or from Homeland Security, and then look at some software attack patterns and the availability of vendor patches within the NVD. So as a part of this research, we want to be able to create these remediation policies, basically ways that industries or organizations can correlate a way in terms of being able to enumerate where they think their likelihood of threat is. Now, in the first examples that we were going through, we first decided to do a test case against, two policies. And the first policy being one where we do a traditional approach, which is we simply rank our CVSS scores from most severe to least severe. And this actually is the way that most industry does vulnerability remediation. Why do they do that? Because it's quick, it's simple, and in the organization's mind, they're tackling the most critical vulnerabilities first. Now, with the second policy, this relevance policy, we want to do something that's a little bit more germane and specific to the organization. So here with this second policy, with this scenario, this organization really has three specific concerns for ranking vulnerabilities. One, they want to identify vulnerabilities that have a very high likelihood of attack, which are based upon those MITRE ATT&CK groups. Next, they want to look to see which ones are easy to exploit. You can categorize vulnerabilities according to whether or not you need close proximity, network access, privilege escalation, things of that nature, which make it easy or hard to exploit a vulnerability. And then we also want to look at which vulnerabilities will have the highest impact to the specific products that are within this organization. And for the test data set, we really just started with the last 20 vulnerabilities that were identified on a particular day. Now, for features, we looked across all of those data sets that were a part of our vulnerability lifecycle, and we used the NVD dashboard to extract some features which we would use for the scoring. We also use one particular vulnerability as our marker for seeing how well our policies performed. And this is CVE 20-1350, which earlier in the year was a vulnerability that attacked a lot of Microsoft SQL Server devices. And it was also one that gained a lot of attention because the Homeland Security basically sent out alerts which said to all federal agencies and even private industries that if you have this particular vulnerability, you need to patch it right away. So let's look at the raw scoring when we take those categorical features and then use them to come up with our relevance score. So the relevance score is basically a matter of summing up the values that are assigned across each of these categories. Now, some data transformation was involved here because some of the information is categorical, such as likelihood of attack, severity of your KPAC design patterns. So we had to convert those low, high, medium to some criteria in ascending and descending order. And then we scored those for each of the vulnerabilities that were released on a particular day. And once we had that sum, that became our relevance score. And we need this relevance score so we'll be able to do discounted cumulative gain for evaluation. Now, in order to measure the impact of the ROI for our particular relevance score, we're going to use a metric which is provided by other research from Furwitz, 2009. And essentially what they did with this research was they presented an agnostic way for being able to assign a metric, and that metric could have any unit of measure that you wanted to each of your severity categories for a CVE ID. So you could assign time, you could assign money, any other type of element you wanted to that resource, but essentially we'll be able to look at each vulnerability and its category, which is based on the score, and then apply this metric for the cost of patching so we can get an accumulative way to evaluate whether or not our strategy for remediation, in addition to the ranking, improves or not. Now, after we calculate the distributed cumulative gain, when we normalize it, we basically start to look at these policies one by one. So with that first policy, which was based upon just ranking by severity, which is in this column here, we see that just ordered by the score, top to bottom, and we see that the vulnerability that we were interested in, that CVE 2020-1350, it gets that #1 spot. And this is the order in which this particular organization, if they use this policy, that they would do remediation, just from top to bottom. Now, when we use the more personalized scoring mechanism, where we actually look at more scenario-based, what we see is that that vulnerability that initially would have been scored #1, it now moves down to #15. And we see that another vulnerability actually takes first place because now it meets more of the characteristics that were important to this organization. We also see an evaluation of patch costs, which, let me go back one. In the original scenario, patch costs, if they were to mitigate the first 10 vulnerabilities on this list, using that scale that we talked about with Furwitz, then patching those top 10 would have cost them 21 patch units, however they choose to term the units. Now, with the new policy, if we were to patch the top 10 based on their ranking order, we see not only that a certain vulnerability is now migrated to the top, but also our patch costs are reduced because now we are patching vulnerabilities which are more applicable to the organization. And those may not be the ones that have the highest criticality score, but they are the ones that meet the criteria set by the policy that was established. Now, if we were to look at this another way, which is not just our top 10, but let's say that most organizations only have, limited IT departments. You may not potentially have a lot of resources to put towards doing vulnerability mitigation. So for an organization that perhaps only had 10 units of patching staff available, we see that with that first policy, which is one in which they were basically going by the severity score only, just from top to bottom, critical to low. And we see that with 10 units, they really could only accomplish getting 3 vulnerabilities patched on a particular day. Whereas if we were to use that more specific policy, which is more relevant to their particular cybersecurity concerns, we see that now that they can patch 6 vulnerabilities instead. So there's a clear difference in terms of not just the coverage with the vulnerabilities that they can that they can remediate, but also they're still doing it at a much lower cost. Now, we are to compare these ranking policies, side by side. We do see that some of the vulnerabilities under the classic policy, just ranking by severity, that some of those actually go down to be a little bit lower on the list. But we also see that a few increase, but a lot of them still remain, somewhere in the same position. And now we are to look at the discounted cumulative gain, which is a measure of our ranking quality. No, Mike. Which is a measure of our ranking quality. And so this is similar to our search engines. If we compare the performance of ranking policy 1 to ranking policy 2, we see that essentially we get a cumulative gain that is essentially, 0.93, which is very close to an ideal ranking for our second policy, our scenario-based policy. And this really gives us a good indication that if we are to work to expand this further, increase the feature set, expand a little bit more on the types of scenarios and ranking policies, that we could have a good approach for really challenging that classic basic CVSS ranking and coming up with what could be a very optimal ranking approach. And that will be the gist of the remainder of the research that I'll be doing. Okay. So for future work, essentially because the data sets that we're using are very, very large, especially when you have to relate them together after doing data transformation and normalization, our goal is really to create these property graphs. These graphs that will reduce the data density and also help us to see these relationships more clearly, because even though a lot of this information comes from very similar or the same sources, it isn't always represented exactly the same way. So we need to do some cleaning, some scrubbing to get these relationships to marry themselves up. And right now we have approximately 1.8 million data points and relationships just for information that was collected between 2018 and 2021. But the hope is that by using this graph-based approach, we'll have a better way to actually see the relationships, look at the cause, the effect, and then be able to come up with patterns that will lead us to the optimal way to come up with the ranking policies. The other thing that we like to do, more data assisted, one is to look at those additional groups for scoring the vulnerabilities. We do understand that the base scoring is just a point in time. And so by also looking at the exploits and patches that are available over time, we can come up with a data-driven approach to inform the calculations of those threat groups, use our specific policies to help inform the environmental groups, and then also to make this more appropriate to looking at a particular cyber adversary as opposed to trying to protect against any and all. We want to come up with this specific adversary metric group, which looks at the techniques, tactics that each cyber group might employ, which data sectors they target, and then if there are any mitigations, which basically defend against the controls that those attack groups have in place. And that is the research that I'm doing.
Great.
Thank you.
Thank you, Corren. We have time for one or two quick questions if anyone's interested.
I have a question. How do you model the relevancy?
How do we model the relevance?
Yes.
Are you talking about in
You
terms of the
propose
algorithm itself?
relevancy-based ranking, right? How do you model the relevance? How do you calculate the relevancy?
So calculating the relevancy, I think, will be a factor of, coming up with weightings for the features that we identify,
Yeah.
and really trying to determine how well they correlate with the exploitability of a vulnerability, or how well they correlate with reducing the mitigation cost.
Right, but like that's my question. Like how? So what the methods did you use to calculate? The score.
Well, in the first example that we gave, the method that we gave was really rudimentary, which was where everything was really equally balanced. But as we go through some machine learning, some classification, we can determine which of those features we should weigh more heavily. I think that's what you're getting at.
I think the answer, Corren, is about deciding what things are relevant to a particular installation.
Oh.
Right. So if I don't have an Android phone, I don't need to worry about Android exploits, that kind of thing.
Oh, so that piece is really about determining what the architecture looks like for an organization. So that's really specific, because we have to remember that you don't have to remediate all vulnerabilities. One, only the ones that affect the hardware, software you have installed at your facility. That one reduces the data set. And then the other piece is also looking at the way that your organization views risk. So when we looked at that scenario in the beginning in terms of, who your attackers are, where they come from and what tactics they employ, that will help with driving the scenarios themselves. So our goal would be to really just look at maybe one or two sectors, like say maybe academia or defense, and then come up with a generalized approach for each of them, and that would encompass what the methodology for the scenarios might look like. Is that
Thank you.
clear? Okay.
All right, any other questions for Corren? All right, thank you so much, Corren. Next up, I believe we have Bhanuka. Can you share your screen? Bhanuka, are you there? All right, you're muted if you're talking.
Okay.
Okay.
Yeah. Can you
All
hear
right,
me?
thank you.
Can you see my screen?
Yep.
Okay, great. Okay. Good evening, everyone. My name is Bhanuka Mahanama. I'm a PhD student with Dr. Sampath Jaratna. And today I'm going to present you about multi-user eye tracking. During the presentation, we will talk about challenges and the developments in multi-user eye tracking. So before moving on to multi-user eye tracking, what is eye tracking? What is eye tracking actually? We can define eye tracking as identifying the location or gaze location of a user. In simple terms, it's identifying where the person is looking at. For example, if I take myself, currently I might be looking at the slides, or I might be looking at the chat window right over the screen. So essentially, what is eye tracking is identifying where the person is looking at. In order to identify where the person is looking at, we use specialized equipment called eye trackers. Depending on how they are developed or built, their construction, we can categorize them into two categories. First one is the head-mounted eye trackers, and the second one is the stationary or desktop eye trackers. As name suggests, the head-mounted eye trackers are wearable eye trackers which resemble a spectacle or a Google Glass or a VR headset. Pupil Lab Score and Pupil Invisible are two examples for these head-mounted eye trackers. In general, these head-mounted eye trackers have 3 cameras: one for extracting the outside world, and 2 for extracting data from each eye. The important aspect of these eye trackers is they move along with the user's movements. In the case of the stationary or the desktop mounted eye trackers, they do not move along with the user's movements. As the name says, they are stationary. In general, when we are using these stationary or desktop mounted eye trackers, what we do is we attach these eye trackers to the surface or the screen that we want to perform eye tracking on. For example, over here, we have a desktop mounted eye tracker attached to a screen. If you take a look at these eye trackers, in general, they are really costly, ranging from $3,000 to $30,000, sometimes including the software that's needed to perform eye tracking. If you take a look at the eye trackers, these eye trackers and their applications in research, we can see some wide range of applications of eye tracking. Some of the applications include, for example, we have user experience testing, where we evaluate the user experience when performing an action. Like, for example, we can consider user experience in a web page. Then we also have market research kind of experiments where we evaluate the behavior of the consumers. Then we also have physiological studies where we evaluate the physiological aspects of the user subject to different types of stimuli. Also, we have behavioral studies where we analyze the behavior of the humans in different scenarios. The main problem with these kind of studies is that these kind of studies are restricted to single subject studies. For example, over here we have two examples for eye tracking in the market research and physiology. As you can see, there's only one participant. Also, these studies are conducted in controlled environments, and usually they are conducted in a laboratory setting. As a result of these two factors, we are losing some valuable information. For example, there can be human-human interaction when in a consumer. There can be valuable insights from human-human interaction for a consumer deciding on purchase of a product. So in order to tackle this problem, it is important to conduct these kind of experiments in the real world or in the wild with multiple users and interactions between these users. That's where the multi-user eye tracking comes into play. Extending from the idea of the eye tracking or the definition of the eye tracking, we can define the multi-user eye tracking as identifying the gaze locations of 2 or more users simultaneously. Since we have 2 or more users, they can be physically co-located. For example, they can be in the same room or maybe same aisle in the market or the department store, or they can be co-located, virtually co-located, like in this Zoom classroom. So in order to address these problems, we propose 3 types of eye tracking. So we have 3 possible solutions for eye tracking. One is to use eye tracker for each participant. That means give a eye tracker to each user in the study, or use a shared eye tracker that performs eye tracking on all the users, or to use an approach known as distributed eye tracking. Throughout the presentation, we will walk through these concepts. The first idea or the first solution is to give each user their own eye tracker, which is kind of the trivial solution to the problem. But the thing is, with that solution, the experiment setup can become really expensive. For example, if you have 2 users, you have to have 2 eye trackers. If you have 10 users, we need to have 10 eye trackers for each of the 10 users. As you can see, as the number of users increase, your experiment setup, the cost of your experiment setup is going to rapidly go up. And also there's another problem with this kind of experiment. That is since we have 2 different hardware, there can be interferences between these eye trackers. For example, some of the eye trackers use infrared illumination. So there can be interferences because of those illuminations, and also interferences due to these illumination settings. As a result, this kind of approach for multi-user eye tracking is not scalable for large-scale studies. That's where the other solution, type of solution we can use. So in this case, what we are going to use is, instead of giving an eye tracker for all the participants, we are going to share a single eye tracker for among all the participants. So this is going to be simple because we just have one hardware setup. And since we have a shared hardware, there's going to be less, it's going to be less expensive, and also there's going to be less interferences because we just only have one hardware setup. So the problem with this setup is that none of the current eye trackers in the market do not support this kind of functionality. That means sharing the eye tracker with multiple users. As you can remember, the head-mounted eye trackers, you can't share it with multiple users. And in the case of desktop eye trackers, they are not supported to perform functions like this. This is where our studies in multi-user eye tracking comes into play. Lord. Okay, I ran into some problem. Yeah, I'm sorry, I ran into some problem. Can you see my screen?
The full PowerPoint experience where it just randomly says, yeah, I don't want to show that slide.
Yeah. I'm going to reload and see. Let's see. Yeah, I think now it should work, hopefully. Why?
you can do that slide in non-slideshow mode and then just go back.
Oh yeah, it seems like it's working. Yeah. Okay. That's where we are that's where our multi-user eye tracking experiments comes into play. As the first step of developing these multi-user eye tracking systems, we developed the initial prototype or initial version of the multi-user eye tracking, with which supports only just 2 users. That's the first step or the baby step into our multi-user eye tracking system. Here, what we did is what we did is we first assumed that there's going to be 2 users, just 2 users in the experimental setting, and we also assumed that they are going to be in either side of the screen or either side of the camera. And we defined them as left user and right user. And when in each camera frame, what we did was we tried to identify this left user and right user using face detection. Then once we have detected the faces of these 2 users, what we did was we passed these facial images through a gaze estimation network, which is a convolutional neural network, and estimate the gaze angles. Here is instead of estimating here what we did was like instead of guessing the screen portions, we estimate the gaze angles, which is the general form of estimating the gaze. So the gaze angles are in the form of pitch and yaw. That means whether you are looking up or sideways, and that's the part of the gaze angles. But the thing is, these gaze angles alone doesn't provide any useful information for us, because we don't know where the person is actually looking at. He might be looking up or up or down, but the thing is, like, we don't know where the person is looking at, whether the person is looking at the screen or likewise. In order to convert that gaze information or the gaze angles, your pitch angles into meaningful information, what we did was we transformed them. We mapped them these gaze angles to the screen using a simple multi-layer perceptron network or a simple regression type of a network. The screen to gaze mapping does is it uses these gaze angles and provides information about the gaze portion in terms of the screen coordinate. In addition to the gaze angles, this model, the screen gaze mapping model also uses encoded face portions, which means it provides these encoded face portions provide information about where the face is located in respect to the overall camera frame. In this setup, for the gaze estimation, what we did was we used a simple convolutional neural network, and we trained it with roughly 1 million images with labels of the gaze angles in terms of yaw and pitch. In the case of the screen to gaze mapping, which can vary depending on the experiment setup, because you can be far away from the screen or like really close to the screen. What we did was we trained or adjusted the parameters of the screen to gaze mapping model in the runtime. That means during the experimental setup. And this quite resembles the calibration setup of a typical eye tracker. Yeah, can you see my screen? Oh,
Yep,
okay,
we're good.
Yeah, okay.
And just like 5 more minutes.
Okay, sure. So to implement this proposed system, what we did was we used a web camera, and we used a regular laptop, and what we achieved is we achieved 15 to 20 frames per second, which is like 15 to 20 hertz. And in the demo video we have over here, what's happening is that there's a proctor instructing these 2 users a randomized sequence of objects to look at. So now we looked at how we can do multi-user eye tracking on a physically co-located setting. What about the virtually co-located setting? That's where the distributed eye tracking systems comes into play. So in this kind of experiments, the users are co-located in the same virtual environment. in the same virtual environment. And yeah, similar to the previous setup, we used here. What we use is we use instead of having all the users in the same virtual physical environment, we are having the same users on the same virtual environment. In this case, it's the same web page. For yeah. Here also what we do is we use web cameras and perform gaze estimation or screen gaze estimation on the device. And what we do is we aggregate them to get the real-time gaze portions. For example, in this illustration, we have 2 users and their gazes are aggregated together to perform the final gaze estimations, like the real-time gaze portions. So this is our demonstration setup for the distributed gaze tracking system. Here we have 2 users, me and Himarsha, and we have a proctor, which is Skanda in the middle. And what we are basically doing is we are connected to the same web page, and the laptops in front of me and Himarsha are performing eye tracking on the browser itself. And these 3 devices are connected across the network, and it provides the Skanda with the real-time gaze portions, or the proctor with the real-time gaze portions. In this experiment, we achieved roughly to 10 to 15 frames per second. And this provided like a good starting point for the distributed eye tracking systems. So if you take a look at the applications of this multi-use eye tracking, one of the key applications is the joint attention. The joint attention, what is meant by joint attention is like paying attention to the same object simultaneously. So in the case of joint attention, we can derive joint attention using the shared gaze portions. That means if me and the other participants are looking at the same object, it can be used to derive information about the joint attention. This joint attention is widely used in the teaching and learning environments, and assessing the performance of teaching and learning environments. And as a result, we can use this joint gaze or joint attention in classroom settings and training sessions likewise. In addition to that, we also can use this joint attention in identifying different disorders like autism spectrum disorders and likewise. On top of that, moving further, we can use these multi-use eye tracking systems in the wild studies or in studies conducted in natural environments, which are quite similar to what we saw in the initial setup. The only difference is now the studies are conducted in natural environments. For example, we can do an experiment in market research, identifying different behaviors of the consumers likewise. So moving on to the challenges of these systems. So far, we tried to develop dual use eye tracking systems, both physically co-located and virtually co-located. The first hurdle we come across was the differences in computational capacities of the devices. For example, in the case of a laptop, it has a computational capacity. Sometimes they do not have GPU acceleration. As a result, these gaze estimation and these models can be really slow running on a regular device. And also, as a result of that, we will have a lower throughput. That means lower sampling rate or frequency of operation compared to traditional eye tracker. Another problem we ran into was the resolution and the field of view camera. As you can see in the example in the slide, these 2 participants, even they are visible in the frame, they are ignored because of the resolution and also the field of view. Therefore, those are 2 kind of problems related to camera we need to we are facing challenges with. Also, we also ran into issues with the network and identifying the possible issues with the bandwidth and also the latencies that a network might impose on a distributed eye tracking system. And yeah, that brings us to the end of the presentation. And during the presentation, we talked about the multi-use eye tracking systems, and we identified 2 developments in our lab: dual use eye tracking systems for physically co-located as well as virtually co-located people. And we also identified possible applications and some of the challenges. And that's the end of the presentation. Thank you.
All right, thank you so much, Bhanuka. We have time for one or two quick questions. Anyone?
I have a question. You have
Yeah.
two neural networks in your architecture. What data did you use to train them?
Actually, I'll go to the slide. We have like so many different data sets for the GS estimation networks, because the most common type of the GS representation is the O and pitch angle. So we used a data set containing roughly 1 million images for this one. And this is for this network. It's not really a network. Sometimes we can use a kind of a regression for this one. What we did was, during the runtime, when we are starting the application, it's going to force you into a calibration sequence where it's going to show you some objects on the screen. You have to look at those objects. During that time, we are going to sample some data on that one, and it's going to adjust those parameters.
Okay, thank you.
Yeah, thank you.
All right, any other questions for Bhanuka? All right, thank you so much.
Okay, thank
next
you.
up, I think we have Javedul.
Yeah, hello, person. Can you see my screen?
All right, we've got it. Thanks.
Hello, everyone. I'm Javedul Ferdous, PhD student in the Department of Computer Science at Old University. In this presentation, I will talk about my work on improving the interaction experience with web data records for blind screen reader users. Web data records are integral component of many websites, especially those that present structured information by querying from a database. Examples include a list of products or services such as item on a shopping website, available hotel rooms on a travel website, and so on. Most often, in addition to web data records, the host websites also provide additional support tools such as data filters, sort options, search form, and the page links for the convenient interactions with the data records. These auxiliary segments are typically found scattered around the data records in a way that is convenient for point and click interaction with the visual input devices such as a computer mouse, as people who are blind cannot use a mouse and instead predominantly rely on the keyboard-driven screen reader assistive technology. Accessing the auxiliary segment is not as easy and quick like it is for sighted users. The screen reader users must manually move the focus back and forth between the data records and the auxiliary segment using a assortment of special keyboard shortcuts. Furthermore, the shortcuts patterns to access the auxiliary segment on different websites are likely to be different due to differences in their underlying HTML implementations. This limitation increase the time and the frustration for screen readers while interacting with the web data records. There are, however, exist prior works that strive to reduce the interaction burden of screen reader user in web browsing, including the data record interaction. Many of these previous methods are based on speech or natural language assistance, where a user can issue a spoken or type command to automatically move the screen reader focus to a particular section of the web page. While these assistants are indeed kind of helpful, they have the same limitation as any of other speech-based systems. For example, they cannot be used in all environments. Errors in automatic speech-based system, for example, recognition has always been like an issue and so on. There also have a proprietors that have leveraged special purpose input devices such as Microsoft Dial or a haptic mouse to support convenient non-visual navigation of web pages. A limitation of this approach is open, then the need for additional hardware is that a user has to switch between multiple modalities during an interaction, which can be confusing and uncomfortable at the same time. To provide convenient access to auxiliary segments such as filter and sort options, we designed a pop-up interface, namely InSupport, containing a dummy controls that serve as the proxies to the actual auxiliary segment control present on the web pages. This pop-up can be instantly accessed with special shortcuts, and its contents are dynamically determined based on the current content of the web page. The navigation of the controls in the pop-up is uniform across all the web pages, and the user only needs to know a few basic screen reader shortcuts for this purpose. We implemented InSupport as a browser extension so that it can provide a support for any arbitrary web page containing the data records. InSupport has two core components. First is the segment structure, and the other one is the proxy interface. The segment structure analyzes the web page DOM and extract the auxiliary segment, that is filters, sort option, search from, and the multi-page links using a custom machine learning-based identification algorithm. The content of the identified auxiliary segments is then duplicated and presented to a user by the proxy interface as shown in the figure. All user selection in the proxy interface are automatically translated by InSupport into a equivalent action on the actual auxiliary segment control on the web page. We devised 4 separate algorithms for existing the 4 types of auxiliary segments: filter option, sort option, source from, and the multi-page link. These algorithms all have a similar workflow. They started by first extracting all the candidate DOM nodes by referring to a predefined list as presented in the table. This predefined list was compiled after a manual analysis of 100 web pages from top visited websites belonging to different domains such as shopping, travel, job search, and classified. Then the algorithm extracts a set of encrypted features from the DOM subtree of all the candidates. The extracted features are representing each candidate are then fed to a custom built machine learning model that uses a classification to determine whether the candidate is to be in intended auxiliary segment. To evaluate the machine learning model, we built a data set for each of the 4 auxiliary segments from a common source of 209 manually annotated web pages. Since each web page contains one instance of each type of auxiliary segment, in total we had 209 positive samples per auxiliary segment type. We also randomly pick one negative data point per auxiliary segment type that each web page in order to have a balanced data set having a total 418 data points. For each segment type, we randomly set aside 320 data points for training and use the remaining 98 data points for testing. For training, we explored 2 models, namely logistic regression and multi-layer perception. While both algorithms perform well as seen in the table, the best performance algorithm varied across the segmented types. The keyboard shortcut for navigating our InSupport pop-up interface mostly consists of basic navigation shortcuts such as arrow and the tab keys as shown in the table. The special shortcut to invoke the pop-up interface are set to Control plus Shift plus Z. To evaluate InSupport, we conduct a user study with 40 screen reader users who are professionally in web browsing and JAWS screen reader. The participant did 2 types of representative tasks on travel and shopping websites. So first task was to locate a data record on travel website that matches with the predefined criteria. And the second task was to locate a desirable data records on a shopping website based on the participant's own personal preferences. The participant did this task under 3 conditions. First, using a screen reader only. And the second is using a state-of-art navigation assisted tool called SAIL. And finally, using our browsing extension called InSupport. The participant varied in age between 26 and 64 years. All the participants did not report any motor impairment that affected their ability to use screen reader shortcuts. Proficiency with the web screen browser and Chrome web browsing constitute our inclusion criteria. All participants stated that they regularly access a wide range of e-commerce websites for doing activities such as shopping, searching for job, or browsing the classified. The result for the task complete times and the number of interaction both were in favor of the InSupport condition in compared to the other 2 study conditions. These differences in the performance metrics were also statistically significant. Overall, in the InSupport condition, the participants limited their focus to the pop-up interface, and therefore they spend less time in exploring the web page like they did in the other 2 conditions. The system usability score, the system usability scale score measuring the usability were significantly higher on average for the InSupport condition in compared to the other 2 study conditions. Likewise, another TLS score measuring task workload was significantly lower for InSupport, and the ratings for the individual TLS subscale was more uniform with an obvious pattern. In the exit interview, most participants attribute their favorite ratings to the instant access feature of InSupport, which they said it reduced the number of key presses for navigating web between web page segment. Almost all participants stated that they having a separate proxy interface for accessing the auxiliary segment was important because it helped them to separate their concern, which is use screen reader shortcuts only for navigating within the data records and not worry about how to navigate to the auxiliary segments. A majority of the participants also stated that with the screen reader, they could not explore many data records due to fatigue, and therefore most often they miss most best deals that offer on the website. These participants expressed that as a fatigue and frustration were significantly lower with InSupport, so they can explore more data records and get a better deals. In other quality feedback, 5 participants expressed a desire for remembering the past selection of the filter and then automatically applying in future interaction involving the same or similar data records to mitigate duplication of effort. Half of the participants wish to have all the data record in one single page, as distribution of a multiple page only serve to increase their interaction burden. Our work had a few limitations. First, the data set for building and evaluating the algorithm were relatively small, and moreover, the evaluation was not performed in the wild and arbitrary web pages. The evaluation tool was restricted to very specific environments, such as a Chrome browser, using only English language web pages, and only rely on only one screen reader, which is JAWS. Further work is therefore needed to ensure generalizability of the proposed idea, informed by the study finding, automatic filter selection and the reordering based on the prior user data can further reduce the interaction effort for screen reader users. So we also intend to pursue this idea in our future work. Thank you for listening my presentation. If you have any question, please let me know.
Okay, thank you, Javedul. Questions for Javedul? So I have one question, and have you, what's the status of applying these techniques to helping people with visibility problems solve things like CAPTCHAs? Is that a task that is applicable, like shopping or purchasing a ticket, or these other tasks? Is that how is this resolved within this community?
Actually, so basically, people who have a disability, especially people who are blind, have to rely on a screen reader. So any screen reader, actually, if you use the screen reader, you saw that it will traverse the all segments on the web pages, and it is kind of tedious for them and difficult to go through each of the content to find a specific deals. So that's how we came out and created a proxy interface so that it could reduce the time for browsing the OF data record, and also they can easily find any better deals that are mentioned in the paper.
Okay.
Michael was asking about CAPTCHAs, right?
Right.
So this paper was sort of limited to the data records, basically search results and all those list of things that you get in any typical web page when you are searching for something. So CAPTCHAs, as far as I know, they have audio CAPTCHAs for people with visual disabilities.
Okay.
And those themselves are not as secure, and there are a lot of accessibility issues with those audio CAPTCHAs. And recently, it's like a hot topic of research for accessible computing folks.
Yeah, I was thinking. I mean, CAPTCHA is one part of it, but for example, like Martin Klein at Lano has done a lot of work looking at websites that are actively anti-robot and trying to defeat automated access to things, and that would seem to be in opposition for your general tasks. So I'm wondering, is like, and in addition to sort of these general tasks, have you defined a task like get a PDF out of a digital library without pissing off Elsevier or something like that?
Oh, okay. So basically things that have some kind of access control.
Yeah, well, not just the username and password, but these things are, I mean, they're trying so hard to protect from things like Sci-Hub that they work really hard to detect unusual access patterns or something, and I think try and obfuscate their page. And I'm just wondering if actually using a digital library or a publisher's digital library like Elsevier is like one of the most difficult tasks that you could do.
Oh, that can be a new paper in itself. I don't think anybody has explored that part.
Right.
So yeah, I mean, people usually, it's still in, I would say, trying to make some of the very basic stuff easy to interact with. So what you're thinking is like, futuristic, so to speak. So, I mean, that's a good area to focus on. I mean, if you want to get some papers where you don't have any.
All right. That'll be somebody else's PhD topic, right?
Yeah.
Any other questions for Javedul? All right. Next up, I think we have Lamia. Thank you, Javedul. Lamia, you ready?
Thank you. I would like to share my screen.
Okay. All right, we got it.
Hello everyone, this is Lamia Salsabil. Today I'm going to present my work, a study of computational reproducibility using URLs linking to open access datasets and software. This work has recently been accepted on Psyche 2022 workshop, and I'm really thankful to my advisor, Dr. Wu, for his support and guidance. So URLs, which basically links to open access datasets and software, are very important for the study of computational reproducibility, because since the inception of internet, research papers which basically uses computational methods include open access datasets and software URLs in their work. So OADS are basically very important resources for the for showing the transparency of work, and at the same time, if someone is trying to replicate the computational experiments, so for those people, OADS are very important resources, and also for building repositories, which for supporting computational reproducibility, OADS are really very important. So here I have already used the term OADS. So for the rest of the slides, I'm going to reference open access dataset and software by OADS in short. And also I'm going to use the term OADS URLs, which basically means URLs which link to open access dataset and software. So these are a couple of examples of OADS URLs in this first sentence, and the third one, we can see that these two sentences link to open access dataset, and the second one is an example of an URL which basically links to software. So these are the examples of OADS URLs. So why OADS classifier? Suppose when someone is trying to extract OADS from just a single paper, they can do it manually. But what if there are a lot of research papers? Suppose we are dealing with 100,000 research papers. In that case, when we are trying to do that manually, it's really challenging because it's laborious, time consuming, and at the same time, it's impractical. So in that case, from that point of view, here is the need of something that can automatically identify OADS URLs in papers. It's because it will be fast and time efficient, and at the same time, it can be used to characterize and assess research reproducibility. So in our work, we developed a hybrid classifier and we named it as OADS classifier to automatically identify OADS URLs in a scientific paper. And for our model, we created a data set of 500 samples for training and testing purpose of the classifier. We have also investigated the disciplinary dependencies and chronological trend of OADS in electronic thesis and dissertations using OADS classifier. So now I'm going to talk about OADS classifier pipeline. So in the first step, we took the research papers which are already in PDF formats. So we converted them in text files. We basically used two different libraries. One is PDF Miner and another one is PyPDF2. So while working with the conversion results from both the libraries, we noticed that the text files that were converted by PyPDF2, there were some white spaces removed between words, which basically made it nearly impossible to perform the sentence segmentation task properly. So we further on proceeded with the results that we got from PDF Miner. So after that, we performed sentence segmentation on the text file. We basically used Spaces Sentence Tokenizer for that purpose. And then here comes the extraction of sentences that contains URLs. So we built a regular expression, which is following to detect the URLs in a particular sentence. And then after that, we extracted sentences that contains URLs. Here comes the important task, which is URL classification. So for that purpose, we built a hybrid method, which is a combination of a heuristic model and a learning-based model. So while we built this heuristic classifier, because when we were working with our 500 dataset, we noticed that basically majority of the publishers' URL don't link to open access dataset, and also the URLs that basically ends with .pdf extension, they also don't link to any open access dataset and software. So from that point of view, we built a control list of 54 major publishers, for example, Springer, Wiley, and SagePub. And in our heuristic classifier, our target was to eliminate the URLs that end with either .pdf or link to publishers. So these are the examples of publishers URLs. So in the first sentence, the URL link to publication, which is published by SagePub. And the second one basically is another publisher URL of which is Wiley. So after that, here comes the learning-based classifier. So the purpose was to encode the sentences we have using pre-trained language model. In our work, we compared 3 transformer language models, which are BERT, Distilbert, Roberta, and a document level embedding model, which is Spectre. So for our work, we use a maximum sequence length of 512, and also to avoid overfitting, we use a dropout rate of 0.2. So after the encoding, we got the vector representations we got from the language models. We basically fed them into a logistic regression classifier for the training and testing purpose. I have already talked about the hybrid methods. That is a combination of a learning-based classifier and a heuristic method. So here in our work, we basically built 3 different hybrid models, and we compared their results, which I'm going to show in later evaluation section. So the first one is no heuristic classifier. So in this model, we basically didn't apply the heuristic classifier in neither of the training nor testing data. We just fed them into the language models and got the encodings, and later on performed later on fed them into logistic regression classifier. But for the second model, which is heuristic classifier for test data, we basically applied this heuristic classifier to only testing corpora before sentence encoding. And after that, the remaining sentences we fed them into logistic regression classifier. So after the third one is heuristic classifier for train and test data, which is basically the model where the heuristic classifier was first applied to both the training and testing corpora before sentence encoding. So after that, the remaining sentences that we got from the heuristic classifier, we basically fed them into language models for the sentence encoding. So other than that, we have also investigated in our work if the URLs itself provide any useful information that can improve sentence representation. So for that purpose, we took the original sample set of sentences, and we made 2 different versions of the dataset. So in one set, we basically kept all the original URLs preserved. But in the second one, we basically masked the original URLs with the word URL. So these are 2 examples. So in the first one, we can see that all the URLs are kept intact and preserved in the sentences. But in the second one, the URLs were masked by the word URL. So for our work, for the training and testing purpose of our model, we created a dataset of 500 sentences that contains URLs, and we extracted all those sentences from Core 19 data and an in-house corpus of social and behavioral science papers. So we basically use 2 different class labels. One is OADS and another one is non-OADS. So OADS means, which I have already introduced the term, that it means if that particular URL links to any open access dataset or software, and non-OADS means it's a general URL which basically doesn't link to any open access dataset or software. So in our work, there were total 248 samples of OADS class and 252 samples of non-OADS class. And we also have divided the data, splitted the data randomly into training and testing corpus. So for training purposes, there were total 400 data, and the remaining samples were used for testing purpose. So while we were doing the data labeling, we faced few challenges. Like there were some sentences which were really ambiguous. So in this example, we can see that it says, for more information, see this particular URL. So in the sentence, it neither mentioned anything about the dataset or software. It just says something like for more information, so which is very ambiguous. And seeing the nature or the context of the sentence, it was hard for us to label it as either OADS or non-OADS. So for this kind of ambiguous sentences, we had to visit that particular URL visited the website that those URLs linked to, and while labeling the URLs, we basically focused on determining the nature of the content. And also in our work, an OADS URL may not necessarily be alive. So after that, we used our classifier for analyzing disciplinary distribution and chronological trend. So for that purpose, we used EDD dataset. EDD dataset is a dataset which basically consists of electronic thesis and dissertation. So and at the time of our work, the cited corpus was collected by crawling electronic thesis and dissertation of 42 university libraries. And a fraction of EDD metadata fields have missing data. So most common fields are, for example, here, department, subject. And the dataset contains a large fraction of embargoed EDDs which were published in recent years. So for our work, we randomly selected 100,000 EDDs from the parent corpus, which is for 50K EDDs, and we selected EDDs from 60 different disciplines. And also while selecting the EDDs, we kept in mind, we made sure that the EDDs contained values in the year and department fields. So we also noticed that there was most of the departments which were closely related. So for that purpose, we basically consolidated 60 departments into 18 disciplines using outline of academic disciplines from Wikipedia. So now I'm going to talk about the evaluation section. So we evaluated the performance of our model using precision recall and F1 score. So the first table basically shows the performance for different hybrid models, which I have already talked about. And we have showed the results for only the language, only the results of the language model Distilbert because of the space constraint. And from the results of the table 1, we can see the highlighted from the highlighted portion that adding heuristic classifier for both the training and testing data achieved highest F1 score, which is 92%. And in table 2, we basically showed the performance that was achieved by Distilbert plus logistic, where the performance was shown the performance for all the language models. And from the result, we can see the best performance was achieved by Distilbert plus logistic regression classifier, and the score highest F1 score is 0.92. And if we notice both the results of both the tables, we can say that leaving the URLs preserved in sentence basically uplifted the performance of the classifier. Though URLs, some arbitrary URLs can be out of vocabulary token, but an URL itself can be parsed into some subword tokens. So if those subword tokens comprises of words like dataset, tool, or software, so these can be some good indicators for OADS URLs. So using OADS classifier, we analyze disciplinary dependence. We basically apply the classifier on the EDDs that we got. So while we used our classifier, we extracted over 3 million sentences that contained URLs. And out of them, our classifier identified around 14% sentences as OADS URLs. And also these OADS URLs appeared in approximately 16,000 EDDs, which is about 16.3% of the EDDs in our corpus. In the later slides, I'm going to use the term OADS EDD, which means the EDDs that basically contains at least one OADS URL. And also, we have demonstrated the inclusion of OADS URLs that changes depending on academic discipline. So in this particular figure, we have demonstrated the dependence of fractions of OADS URLs and OADS EDDs for academic disciplines, as we have randomly selected EDDs from the parent corpus. So there might be the case, suppose for example, that we have selected more EDDs from the chemistry department, but less EDDs from computer science department. So just to avoid this kind of bias, we try to show the dependence of the fractions of OADS URLs and OADS EDDs for academic disciplines, and we basically use this particular these two equations to calculate that. So from the result of figure 1, we can see some interesting results. For example, computer science has the highest fraction of OADS EDDs, which is about 50.2%, and the EDDs in social sciences like political science, sociology, anthropology, it contains a relatively higher fraction of OADS EDDs than STEM disciplines like engineering, biology. And we also, from the observation, we can see that certain disciplines like chemistry, business, they have a very small fraction of OADS EDDs, which are even less than 10%. We also showed a chronological trend using EDDs. So here in this figure, we can see the number of OADS URLs and EDDs containing OADS URLs as a function of publication here. So from the figure, we can see that there has been a significant increase of OADS EDDs and OADS URLs from year 2005, and it kept continued till 2015. So after that, we can see there has been a significant amount of decrease in the EDDs. So as we selected the EDDs from the parent corpus, and the parent corpus itself did not represent all the EDDs in the United States. So and also a substantial fraction of recent year EDDs was embargoed. So this can be the reason for the trend being like that. In figure 3, we have demonstrated the we have demonstrated that a fraction of OADS URLs and EDDs containing OADS URLs as a function of year. So from this figure, we can see that the fraction of OADS EDDs has been gradually increasing over the years, from less than 5% in 2000 to more than 25% in 2010 to about 40% in 2020. So there can be some probable reasons for the trend being like that. One reason can be that the reduction of including OADS URLs in EDDs. There can be that the increase of non-OADS URLs in EDDs, and another probable reason can be that the selection bias due to the weak correlation between embargoed EDDs and the inclusion of OADS URLs. So the experimental results of our work are preliminary because we have worked with a very small relatively small data set for the training and testing purpose, and the samples were drawn from COVID-19 and SBS dataset. And also further investigation for the trend shown in figure 2 and 3 is needed. So currently we are working on to build a larger corpus for training and testing purpose, and for that and we are gathering data samples from multiple disciplines, unlike in our recent work, which were drawn from only COVID-19 data and SBS dataset. And we are also working on to develop a multi-class classifier to distinguish whether OADS URLs linked to a dataset or to a software, and also whether those OADS URLs are published by the authors or included as third-party resources. So for future work, we are also trying to gather a more complete sample so that we can reveal more accurate trend and dependencies after year 2016. So in summary, in our work, we studied the computational reproducibility using OADS URLs, which focusing on ETDs that were collected from USA universities. And we developed OADS classifier to identify OADS URLs automatically. And our classifier achieved a best F1 score of 0.92. And we have also demonstrated disciplinary dependency and chronological trend analysis using OADS classifier. So our analysis for URLs in ETDs, we found that the inclusion of OADS URLs exhibited a strong dependence on disciplines. That's all about my research. Thank you so much.
All right, thank you so much. And I know Vicky, who's a guest of ours here. And Vicky, you have some questions for Lamia, right?
Yeah, sorry, I just had one question. Hi, I'm Vicky Rampin. I'm the librarian for research data management and reproducibility at NYU. And this is super interesting. I was wondering about the specific connection to computational reproducibility, because it is such a specific, it refers to a specific thing, which is rerunning someone's research workflow and seeing if you get the same result at the end. So this I see as a very nice first step to that. Like before we can rerun someone's materials, we need to find them, certainly. But I'm just wondering if you can elaborate a little bit more about what you'd like to do around computational reproducibility specifically. Thank you.
Thank you so much for your question. So, so a dataset or software are good sources for studying computational reproducibility. So in our work, what we did, we used our classifier to apply on the ETDs that from an existing ETD corpus. And we basically showed the trend, the chronological trend, and as well as the disciplinary distribution. So that's what how we basically analyzed and worked towards the computational reproducibility in our work.
Okay, thank you.
Okay, so Vicky, thanks for your interest. I'm Jian Wu. I'm Lamia's advisor. I think I can address some of your questions. So I'm thinking about this computational reproducibility because so recently a lot of reproducible work on experimental level has been done on social and behavioral science, and right, so we have been trying to reproduce the results in the social science papers. However, there's not a big effort in terms of computationally reproduce the result. So before we do that, we need to select the candidate. We need to see which papers that's possible for us to reproduce. So this will be the first step for us to identify, to automatically identify this research works that could be reproduced computationally. So
yeah, that makes a lot of sense.
Right. So in the next step, we're going to have a fine granular classification in terms of whether the URLs are linking to are provided by the author or by the third party. And furthermore, we can try to identify whether there's any connections between the data and the data URL, the software URL, and the claims that's extracted from the paper, right? Because essentially, I mean, this URLs can be distributed anywhere in the paper, but some of them might be associated with the claim, right? So after that, that will help us to narrow down our search space. So say when we want to reproduce that claim, what the data do we need, and what the software do we need? So.
Yeah, thank you very much.
Sure, thank you.
All right. So Lamia, I have a question. This is something, there's some natural synergy, as you'll see, of what you presented and what Emily will be presenting next. And one of the things that we're planning on looking at, and I wonder if you did as well, is where in the document these links occur. Do they occur in the text? Do they occur in footnotes? Do they occur in references? And is there any distinction or classification based on where they occur?
Thank you so much for your question. So in our current work, yes, we have some URLs that were extracted from text, and also some of them are from reference section. But in our current work, we don't have those kind of classification, like whether those URLs were from reference section or from the text or from footnote. So that's really a good, an interesting insight. Maybe as currently we are working on some future implementation, we can use that suggestion. Thank you.
All right. So I'm going to, do we have any other questions?
I can ask a few.
All right. But we need to, maintain the synergy to launch into Emily's presentations.
All right. Yeah. So, I mean, one question that reviewers might ask, like, if you're dealing with scientific data, and of all the birds that you use, why not Cybird?
Thank you so much for that, for your question. So Cybird was basically trained on scientific papers, yes. Maybe we can try that in our future work, but we used Spectre, which was trained on document level embedding.
So let me answer that question. So both Cybird and Spectre were proposed by alumni, right? And actually, Spectre was proposed after Cybird and was designed to address the weakness of Cybird by incorporating the connections between documents. And in their paper, they explicitly evaluated the Cybird against the Spectre and found that Spectre has a better performance. So that's why we choose to use Spectre.
Awesome, thank you. And the next question would be about, so the classification, I think one of the URL classification you presented was from Wiley or something, where basically you were trying to figure out if the URL is from a publisher, right?
Yes, that's what.
And how did you do that? Did you use like a dictionary of publisher domains or some sort of other heuristics like content on the page or something that tells you this is a publisher page?
Yes, we basically built a list of 54 major publishers, and we publisher names. And when we figured out that particular name, I mean, we basically divided the URLs into subtokens, subword tokens, and we tried to figure out whether that particular URL name was in, that particular publisher name was in that URL. So if we, if it could find out that, then we, the heuristic classifier basically eliminated the URL from the list, the sentence that contained the URL.
Thanks. And one final question: what can we do from the Internet Archive or other web archives as we have the infrastructure to hold some of these research data, and going back to prior papers and identifying sources of data that are lost, what can we do to kind of find it in web archives and patch those documents somehow, like putting an overlay or something?
In our current work, we already mentioned that, if I understood your question correctly, that an ODS URL may not necessarily be alive. So we just basically either saw the context of the sentence, whether it somehow it gives us the hint that whether that link to any open access dataset and software, on the basis of that we perform the labeling task. But it can be the scenario that those URLs don't link to those URLs link to websites. Those are not there right now. So in our future work, yes, Dr. Ru proposed for to like investigate also whether the URLs that links to the website are alive or not. We are working on that also.
All right, thank you. That's it from my side.
Thank you so much.
All right. Thank you, Lamia. Emily, ready?
Yep. Okay. Okay, yeah, should be sharing my screen now. So like Dr. Nelson already alluded to, there's a lot of similarities between what Lamia just presented and what I will be presenting. So I am going to be talking about archiving source code in scholarly content. 1 in 5 articles reference GitHub. And I'm working with the COSI team, which includes Vicki Rampin and Martin Klein. Vicki had just asked a question previously, and we're funded by the Alfred P. Sloan Foundation. So, okay. So all of us have probably seen a link to GitHub or another repository as we're going through scholarly content. Lamia definitely has with her research. And here we see a link where an author is saying, this is the code product that we made that we're explaining in our paper. Here's the link to it. But when we go to that link, it's no longer available on the live web. So if we go to the Internet Archive to check, do they have it? On the left, we see initially, yes, there's a capture from June 2018 that looks like they have this repository that was linked in that scholarly publication. But just going one click deep and looking at their commits, we see that it's not complete. They have 1,500 commits and we can't see them. And if you're familiar with GitHub, you know that commits are essentially a way of almost self-documenting code by noting what changes you're making to the code base. And the fact that we're missing them is a large part of what's in the repo and helping the repo make sense for someone coming in afterwards, looking at this product or from the perspective of reproducibility. So like I just mentioned, we're seeing a trend of an increasing number of links to Git hosting platforms in scholarly publications. Git hosting platforms are platforms that are based on Git version control system. You might be familiar with GitLab, GitHub, SourceForge, or Bitbucket. All of those are Git hosting platforms. And we're seeing an increase in links in scholarly publications to GHPs. But they're not permanent. In one of my undergrad CS classes, they introduced GitHub to us, said we're going to be using this for the class. It's good for version control system, but also it's good to have a backup of your assignment so that if your computer crashes, you never lose your code. So there's always this idea of permanence. When I was first learning about GitHub and what it offered of it's more stable than your laptop. And while that's true, these GHPs are not an archive. So if we see on the right, we have Google Code here and Gitorious, and those are both platforms where people put their code in there as potentially as a backup, saying this is where my code will live forever. But those two platforms no longer exist because Git hosting platforms are not an archive. So we're talking about archiving scholarly content. Scholarly publications are well preserved. Things like Locks, Clocks, and Portico do a great job of archiving scholarly publications as a whole. But they do not archive the links to the web or to source code that might be coming from those publications. But authors include links to things when something is important to their study. So a URL indicates that something is important or worth noting, is a part of their research done, but that's not currently preserved with Locks, Clocks, or Portico. Some Zenodo and software heritage are two tools and efforts that are currently very popular for preserving code. They maintain versioning very similar to how GitHub allows versioning, and you're able to download the code even from a specific commit. So it's very useful, but it does not capture the ephemera. And ephemera is just the content or the context surrounding the source code. So this might be issue threads, pull requests, or wikis, that all of these come together to create the context of the source code that we're looking at. And Zenodo and software heritage do not come from a web archiving perspective. And what I mean by that is the Memento framework preserves context. So if August 7th, 2019, we archived odu.edu, we want it to, we preserve it in a way that someone can look at it today and see exactly what someone saw August 7th, 2019. But that's not what Zenodo and software heritage do. They pull the code out and essentially function as another repository in addition to GitHub. But again, these aren't permanent. Even on Zenodo's website, they say, we guarantee we'll be around as long as CERN is around. But like we've seen with other things, that's not a guarantee of permanence. Additionally, being able to archive the ephemera adds context to the code. So for one of my classes, we're using D3, and D3 in the issue threads in GitHub, you can see people talking about, the same issues that I've experienced and how other people worked them out, or they just had a recent release and people are bringing up issues. And so you can see the conversation and the patches for those issues. But all of that creates context. All of that tells a story about how did the code get to where it is? Why are things the way that they are? And you can see the conversation surrounding the code. But if you don't capture the ephemera, you don't have that context. Additionally, GHPs are different than typical web pages in that if you're missing a file, it breaks a lot more potentially. So if I'm missing the CSS page on my personal web page, that might affect how things look, but all in all, I can still see a web page even if it's broken. But if I'm missing a main file on a code repository, I potentially won't be able to run that code at all. Just with the way that code is interconnected, that might be a really important file that I'm missing, and now the code doesn't run at all. So GHPs require a higher level of completeness, especially as we're talking about reproducibility and being able to run this code again. So in order to address this problem, we first want to understand the scope. So how are people using linking to GHPs in scholarly content? So we looked at the archive corpus. Archive is a STEM preprint service, and we use it as a representative sample of STEM publications. It is huge. They have over 2 million submissions. Also, it's publicly available, so it's not behind any paywall or anything like that. And it allows for programmatic access, which is super important when we're looking at 2 million submissions. For our analysis, we looked at publications from April 2007 to 2021. And we also assumed that the latest version of each submission was representative of what the authors was most representative of what the authors wanted to publish. Okay, so in our analysis, we looked at 1.56 million publications, like I said, a really large corpus. And we found over 4 million URIs to the web at large. And these URIs, we excluded any links to archive or any DOIs, assuming that things like Locks, Clocks, Portico, that those offerings probably archived these things. And then we also excluded any links to localhost or IP addresses. So outside of that, we had 4 million in-scope URIs that were referencing the web at large. And we found over 218,000 URIs to these 4 GHPs: GitHub, SourceForge, Bitbucket, and GitLab. Vicky Rampin's work, she found that these were the 4 most commonly used GHPs in academia. So that's why we chose those 4. And you can see with this bar chart that GitHub is overwhelmingly the most popular GHP referenced in scholarly content, with over 92% of GHP URIs going to GitHub alone. So when we look at just the overall trend of URIs over time, we see like a little around 1, average of 1 URI per publication in 2007. Now we're up to close to 4.7 URIs per publication. So there's been a significant increase in the prevalence of URIs to the web at large, but we're also seeing an increase in links to GHPs as well. And then we see a significant spike in the number of publications that include a link to GitHub, starting around 2014, have a significant increase now to where in 2021, there is an average of 1 in 5 publications contain a link to GitHub. So like we mentioned earlier, GitHub is very prevalent within scholarly publications. Okay, then next we want to look at kind of the prevalence or frequency of these links. If a publication links to a GHP, how many links does it contain? So if we look at kind of the first intersection here, we see that 33% of publications that reference GitHub more than 2 times. So that was saying 67% reference it only once, but 33% reference more than once. My slides aren't moving. Okay, great. So also 17% contain 3 or more publications. And then we start going down to the tail. Oh, goodness. Okay, we start going down, looking at the tail, we see that 0.687% of publications contain more than 10 GitHub URLs. But while that looks like a very small percentage, and it is, this still represents 863 publications that are referencing GitHub more than 10 times. And this is significant because if we have this idea that someone's only linking to something if it's important, then the fact that they're linking to GitHub more than 10 times means that they're putting a heavy emphasis on the holdings of GitHub for their research, whether that's citing a tool that they made and they're linking to that tool, or a tool that they used in their study. And we also see like this long tail goes way out. We have 160, 140 links, and it's not shown here, but we'll talk about in a moment. There was even a paper that referenced GitHub 896 times. So there are papers that are putting a very, very strong emphasis on the holdings of GitHub for their study. So this is that paper, 896 links to GitHub. It's a lot of links, obviously. So this is a comparison study between open source container orchestration framework. So they're looking at different offerings of Kubernetes, Aurora, Marathon, that kind of thing. And a lot of those links are existing in tables like this, where they're comparing different features. And so all of these blue little check marks contain a link, and most of them to GitHub, because that's where this documentation lives. So they're linking and saying this feature and its prevalence is shown here in this documentation. So they're linking to GitHub as a way to link to this documentation. This is one of many, many tables throughout this publication where they're doing an overall comparison study. And so this is a great example of, if these links stop working, this publication changes drastically. The context behind all of this disappears essentially. And so that's just a great example of, this is the importance of archiving the holdings of GitHub, because GitHub is not permanent. Just like anything else, it can go away. But for the sake of reproducibility and completeness of research, we want to be able to see this publication and all of its context forever. So some just key takeaways, GHPs are not permanent. They are subject to the same ephemeral nature of the web as the rest of the web. And links to GHPs are increasingly prevalent in scholarly publications. We're seeing that 1 in 5 publications contains a link to GitHub, and 92% of GHP links are to GitHub specifically. And there is a need to archive GHPs to preserve the scholarly record. With that, does everyone have any questions?
Questions for Emily?
So Emily, I just want to make a quick comment. I'm very excited about this because you showed that the average number of this GHP in 2021 was around 4, right? This is consistent with our finding. Actually, Lamia has another plot that she didn't show in her presentation. We actually plot the number, the average number of OEDS around time, and it's actually increases from 2 to 4, and in year 2020 is about 4. So
cool. Yeah, that's awesome.
Not this one.
This one?
Yes.
Oh, this is the blue line is the web at large. So we're seeing over 4 URIs to the web at large in 2021 for the archive corpus.
Oh, okay.
But there were lots of URLs of that would be considered in scope for you, but we were looking specifically for github.com, gitlab.com, etc. Not the departmental tilde sites /data.html, etc.
Okay, so these are all the URLs.
Mm-hmm.
Okay, then there's a little bit difference. I mean, so your GHP URL is so this is the average, right? So yeah, so the average for publication is about 0.5. Yeah, but ours is around 4. But we use ETDs, and ETDs are longer, right? And one ETD, suppose ETD contains 4 chapters, and each chapter will contain equal number, so multiplied by 4. So
yeah, because we're looking at the archive corpus, so you're not going to be publishing an ETD most likely in archive, so that's slightly different.
Interesting.
Yeah,
nice work.
Thank you. Question from James, I think.
Hello. Yeah, this might not actually be a question. It's kind of either a comment or a wish list for future work. But I'm going to ask you if in the future there's any plans to actually make being able to clone the repositories through the archive versus maybe I'm not sure, but maybe to me this looks more like a web view only kind of thing. Would we be able to actually access through that, like some kind of
yes? That is part of the really exciting work that we're doing with COSI. So like I mentioned, this was just kind of quantifying the scope of the problem. So we are working with Wilkie from University of Pittsburgh. They are a expert on Occam. And then we're also working with Martin Klein, like I mentioned. So and he came up with a tracer framework. So the end goal of all of this is to use the tracer framework to create better captures of GHPs and being able to use the Occam framework to be able to replay those repositories with all of their not contingencies, with all of their requirements, like different libraries and stuff that they bring in. So yeah, that's the end goal.
Well, yeah, I was imagining FPGA cores on some cluster being able to run a machine at that time. So say it's 2080 and I want to run code from 2012, maybe architecture then doesn't really allow you to play the code back. So maybe there's some kind of thing you can pull all from archives and create a container that can run everything.
Yeah, that's exactly.
Can I field that, Emily?
Yeah, go ahead.
Sorry. That is exactly what we're trying to do. There's a part of COSI that specifically works with the emulation as a service infrastructure project, which is exactly that, providing access to emulated older systems to be able to rerun code. So what we're interested in with COSI is situating computational replay next to archived materials. So that's very closely connected as a part of the work.
Okay, that's super rad. Thank you.
All right.
I have a few comments and questions. One was, I think it was briefly touched by Dr. Wu. When you said like average number of GHPs per paper, some sort of normalization based on the length of the document, which could be like word counting in that case, or all the other links that are present. So if the paper has 100 links, and out of those 100 there are like 4 that are GitHub, or a paper that has 2 million links and 50 are GitHub, like I don't see that same equivalence, and that will automatically encapsulate highly linked papers or papers with too much word and ETTs in this case. Maybe that will be an interesting thing to look at and see that graph, how the shape changes, if at all. The other thing was a comment on your usage of the term archive. And I understand what you meant when you said GHPs are not archives. The same WSDL team has this argument. They call wikis and Git and any other versioning system, we tend to call them as a form of archive. So the permanence or longevity that you expect from an archive, I don't know if that is embedded in the term definition itself. Maybe being a little bit careful in how we use these terminologies will be safer. Yes, I mean, and when you say archives go extinct as well. We are talking about web archives, and in my 1 decade of web archiving career, I've seen many of those. So figure out what is the best way to communicate the permanence versus using archive as a loaded word in this case.
Yeah. Well, and the point of having multiple archives, right? Like Archive It or Internet Archive, or UK has an archive, all of these different ones, is that if one goes down, it's still somewhere else. But the problem of not being able to correct or completely capture these GHP repos, I think persists across archives, if that makes sense.
Yeah, one problem that we had at the Internet Archive to archive GitHubs, for example, we put a lot of effort in archiving GitHub, and we have partnership with them. But archiving their web rendition versus the source code using Git tools, there is the difference that lies. And since we are serving our archives only via HTTP, it kind of becomes tricky to pull down Git repositories using Git command and then serve it over HTTP, because then it will require us to have extra tooling that understand Git, something like Git or something, and says, hey, here is the Git repository, serve it as a web presentation or something like that. And in that case, it will be kind of morphed, or it's like downloading JSON from YouTube, from Twitter, and putting up your own wrapper around it to kind of to build an HTML representation around it, versus just preserving the representation itself.
Mm-hmm. Yep.
All right. Any other questions for Emily? All right, so we'll get on to the next portion, I guess. Let me see, we've lost a number of our alumni. Everybody had to go at 4 o'clock. We've lost Martin Klein and Frank McCown. I think they described themselves in the chat. Frank was my first PhD student. Martin was my 3rd PhD student. Let me see, we've also lost Matt Kelly. Most of you guys know him. He's at Drexel. Alexander Nwala, he graduated 2 years ago, was at Indiana University, and he'll be headed back to William & Mary starting in the fall as a tenure track professor. So we've got a few more alumni on the line here, and I'd like to give them a chance to introduce themselves to everyone. Dhruv, are you still there?
Oh yeah, can you guys hear me?
Yep, we got you. So Dhruv, you're still in Austin, Texas, right?
No, actually, I ended up never moving to Austin, Texas.
Oh, okay.
I got converted into a fully remote employee, so I'm still in Virginia.
Okay, all right.
Yeah.
So tell us what you're doing, and when you graduate, tell us who you are, when you graduate, what you're doing.
Yeah, sure. So my name is Dhruv Patel, and I graduated last year, in fact, with a master's in CS. And in fact, my master's project was part of last year's Expo. After graduating, I joined Cox Automotive as a as a software engineer, where I recently moved up to a P2 level software engineer. And I've had the chance to contribute to the development of highly scalable, highly available single sign-on platform for all the solutions offered by the company, as well as some internal tooling that aggregates data from all the different solutions and manages editing and viewing internally. In addition to that, I've had a chance to wear a few different hats, such as setting up cloud infrastructure, doing some severe testing and whatnot. Every now and then I'll slip in some bugs to fix later. Just kidding. Yeah. So that's it.
All right, thank you. Let me see. Terry, are you there?
Hey, can you hear me okay?
Yep, got it.
Okay, well, it sounds like Dhruv and I are the alumni that had the endurance to make it all the way to the end here. So first off, this is about the students. So congratulations to you all on all your hard work. I've been in your shoes. I've been in the labs all night until they throw us out and all that. So I didn't know how I would survive at some points, but eventually you do get caught up on sleep. Yeah, my name is Terry Harrison. I graduated with a master's in CS in 2005. I just took a few notes real quick to keep me on track here. I kind of followed an untraditional path in getting my master's. I graduated at about 35 years old. And then I would say the master's gave me a good stepping stone for getting into IT management. I've worked with many companies, large, small, family-owned, Beltway bandits, federal contractors. I've worked for Volkswagen Group National Headquarters, or Volkswagen Group of America, Navy Federal Headquarters. And finally, I'm now with the federal government working with the U.S. Citizenship and Immigration Services. USCIS, for anybody interested in the federal government, a lot of people think the federal government is backdated, bureaucratic, slow, and those things are probably true to some extent. But USCIS is, I would just put a pin in that as a memory, that it's one of the most advanced as far as IT goes. And by that, they are on the cutting edge of Agile for the federal government. We do continuous integration, continuous delivery, and we roll out code far faster than I have at any other place that I've worked at, some at a daily level. I had just a few tips or takeaways from some old guy that graduated a while back. So if I looked back on a couple of things, I didn't want to be a developer forever. And if that rings true to you, and maybe if you're, just in case you're not continuing, I know Michael will want you to continue in academia, but just in case you decide you don't want to.
Sorry, you're breaking up, Terry. We're going to have to let you go now.
I'll turn up the volume. So there's another option, and what ended up working out well for me, nice for me, was actually project management. And I'm going to go back to the master's degree. That the master's degree really gave me a good solid foundation that I could use in IT. Even though I wasn't the developer, I could really have those conversations with the developer, with the system admins, but also have the communications with the business and kind of bridge that gap. And I found that that's what sort of my strength was. But no matter what your path, building up your dev chops come in really good and handy for being able to have those communications. I'd say the key to being the most effective in your job, whatever it is well, doing good work, being good at it, but also building up those relationships and having the camaraderie with your colleagues. So that makes the work a lot more pleasant, which is an important thing. But it also gives you multiple ways to solve a problem. You can go to a colleague and they'll be willing to talk to you and share with them, and you can eliminate problems a lot faster. And finally, if you are interested in project management or ever do become interested in that, then I would just give one hint that the key to kind of getting past the HR auto processing, first gate is the PMP, or Project Management Professional Certification. That's a good checkbox item just to have in your arsenal along with your master's degree. And the funny thing is, unfortunately, HR departments may not appreciate the master's degree as much as they do a simple little certification to get. But the certification might get you part way through the door. The master's degree will kind of keep you there. So that's pretty much me in a nutshell.
All right, thanks, Terry. And did you mention that you worked with the Library of Congress? Yeah.
No, yeah, I did that to another federal agency stop. Library of Congress may be a little bit more resonate a little bit more or closer to home here with the type of presentations and the digital libraries and the repositories. Yeah, I did 6 years working as a federal contractor with them. Very good experience. That's in DC, so it's not too far away. It's an opportunity. If you have an opportunity to do that, they have some great work going on there.
I like how you referred to it like it's San Quentin. I did 6 years there. I did my bit.
Actually, it's because of the Library of Congress that I moved to the DC area, and it was a great stepping stone. Getting into the federal government is really tricky. I tried to get in the Library of Congress for a number of years, and those HR processing systems just kind of are tricky. So if you do decide to go the federal government route, be patient. Take the application seriously and spend a lot of time on them. I think I would spend 4 to 6 hours on each application for each job that I did at the federal government. And that's after having a tuned resume and all that stuff going into it. So just take it really seriously, because it's a golden thing to have if you can get a slot there.
Excellent. So with that, that's a good launch to Sean. You want to go next?
Yes. Hi, everybody. Oh, you hear me okay?
Yep.
Okay, cool. Let's see here. My name is Sean Jones. I now work for Los Alamos National Laboratory as a postdoc. I did used to work for the United States Navy as a software engineer and a variety of other things for 18 years. And I resolved that that wasn't going to help me grow and become the person I wanted to be. So in 2010, I decided to go back to school with some encouragement from my wife. And my original plan was to just get a master's degree so that I could get a different government job somewhere else. And, basically kind of like Terry, lead some project or something. And then I realized, and part of this is Michael Nelson's fault. I like research. So I decided to go ahead and continue after the master's degree. And I got my PhD in 2021. And I also was able to, thanks to help from Michael Nelson and Martin Klein and other people, secure a job working for Diane Oyen at Los Alamos. I now work on a project called Go Figure. With Jian Wu and some other folks also from ODU. And I also do some other things at the lab. I'm still navigating the process of being a postdoc and being a researcher at a government institution. That's a little different than being a PhD. And some folks have been helping me through that. It's interesting because if you present ideas to the folks at the lab, they will fund them internally. And you can get publications and things that way. But they're also very, very interested in taking a peek at what you're doing before you publish. So keep that in mind if you go work for a national lab. It's awesome. There's all kinds of resources. There's all kinds of support and everything. And they'll do everything to help you out. So I have to say I'm pretty impressed. I'm hoping that within the next year, I'll be able to move on from postdoc to scientist. That's the next step. And then I will actually be a full-time Los Alamos employee, and I'll be a scientist, which has been my career goal.
All right, thanks, Sean. And as Martin mentioned, we're eager to keep the ODU LANL connection. So Danny, there's just a little bit of pressure on you to come here and join us.
Oh, definitely, yes. Yeah, we'd love to have you. Yeah, we've definitely been trying to keep the connection going with students going both directions.
Yep, well, it's done really well for us. All right, and let me see. I think the last alumni that we still have with us is Saud. I'm sure everybody knows Saud now, and who just had his biography published by the Internet Archive. So everyone has read and retweeted that, I'm sure.
Yeah, and unless you know Saud, you won't be able to graduate from WSDL. That's a new condition, right? And of course, if you missed that biography, here is the link. Go read it. So I don't have to repeat the whole thing here. I'm a web and data scientist at the Internet Archive in the Wayback Machine team currently. And if any of you are willing to work with the Internet Archive as an intern for a while, I'm right there. Contact me and we'll figure something out. Other than that, if your research needs require interaction with the Wayback Machine, dataset, or APIs, talk to me. That's about it.
So sort of like Dhruv, I guess, and some of the others, even though you're at the Internet Archive, you're still here with us in Norfolk, right?
Yes, I'm perhaps closer to the campus than anyone in this call. Yeah, like literally across the road, there are like, one of the ODU buildings. So I didn't have a reason to move to West Coast and, spend the money in housing that I can spend in paying taxes, which I filed yesterday, by the way.
Yeah, certainly it's, cost of living in San Francisco area is outrageous, right? And Norfolk, right, you can live quite comfortably. So I know Terry knows a little bit something about cost of living up in DC area, right? So.
Well, people move to Northern Virginia side to kind of, save a little bit and still work in DC, right?
Right. So I was hoping, well, Dhruv, we're happy that you're still here in the area. I was hoping you would regale us with tales of how awesome Austin, Texas is, though, because it is a very cool town. So
I should be visiting sometime next month or something, because there is a requirement of my team in particular to meet about once every quarter.
Okay.
So we haven't had our first visit yet. That should be coming up soon. So hopefully I have stories for you. But,
all right. So there's plenty to see and do in downtown Austin, but can hitch a ride to the outskirts. There's a place called the Broken Spoke, and it is just like every dive that you see in a movie, like Roadhouse or something. It's an awesome place. But and of course you have to do the bats and everything else in Austin. I was trying to think. Terry, were you with us when we did the bats in Austin?
I don't know if you're saying bath or bats. Like
bats.
Batman?
Yeah.
Bats? Oh,
yeah,
no.
I think that was Martin. Yeah. So yeah. Austin's a lot of fun for sure. Absolutely. Yeah. All right. I think we covered everyone.
I wanted to point out while Dhruv is here that he worked for the Internet Archive as an intern for a while, and we were very happy to have him around. And he certainly had a very good impression of the lab in our team at the Internet Archive, and we want to maintain that relationship and and reflect the kind of scientific and developer background that is built here in this team.
Yep.
Yeah, it was a pretty good experience. It obviously gave me a little bit of a taste of what I do now. So it's definitely like a good opportunity to, I guess, if you're still in the exploring phase, maybe you might want to go the route Terry went, but you're not sure. Internet Archive would interning there would be a good start for sure.
Yep. So talk to Saud. He can hook you up. And Saud, the way they do it, it's easy for non-citizens to work there, right?
It's a lot easier for citizens, but anyone who can have an account in Upwork and get payment from there, like as a freelancer, figure out the logistics around that. And that actually, hiring someone as an intern and paying as an hourly, pay doesn't require going through the hoops of, getting things signed by Brewster or, the top authority. It can be done at the manager level, in each team. So they have some fun to kind of, get hourly job done and they can pay from there. That's how it makes things a lot easier that way.
Right. So I perhaps misspoke by saying easy. Perhaps it's possible or
it's possible. And like very recently, Kritika worked with us, and she certainly is not. Yeah. So talk to her how she navigated the documentation.
Right.
I would say I was on permanent residency and I was able to sign up for it. So if that's of any help, yeah.
All right.
I just wanted to give a last minute plug for Los Alamos does have student internships, a lot of summer stuff. So I'm going to post a link in the chat. I believe that the due date for the summer is past at this point, but keep looking, and we have different things at different times of the year. So you might not be working with me. You'll probably be working with Martin. You might be working with both of us. We work on different teams. So just FYI, it is an opportunity. Take advantage of it if you can.
So I think Govinda, Yasif, you guys will be interning perhaps remotely at the lab. Is that right?
Yeah, I guess. Yeah.
Okay. All right. So we've got at least 2 people this
And hi,
summer.
Marcia.
All right. Hi, Marcia. 3. Yes, right. So we'll have 3 people at the lab, I guess virtually at the lab this summer. Right. Sorry, I forgot about her, Marcia, as well. All right.
Yeah, I just got the email about her, which is awesome.
Okay, excellent.
I was gonna add on that. Well, if anyone has any interest of joining Cox Automotive and needs a referral or anything, feel free to reach out to me as well.
All right. You want to put your email in the chat?
Yep.
I don't know if your ODU email still works or not. So.
And I've got a tiny little plug. It's actually kind of funny because it's relevant. If you want to explore your eligibility of working in the United States, that's one of the apps that we do at Citizenship and Immigration Services. It's called MyEVerify, and it's the self-directed version that that you can do on your own. I'll put it in the URL there. E-Verify is when you go get a job and you bring in like your passport or your driver's license and they verify your eligibility to work in the United States. That's what the employer does. MyEVerify is a chance for you to go in and you can basically try it yourself and see what your statuses are. So that may be of interest to some folks.
I don't see it in the chat. Did you press return?
I did. Let me see. I'm doing it. I'm on 2 systems. So
or did
if
it send a private message to somebody?
Oh yeah, I sent it to Shaw by accident. Sorry about that. I don't know how I managed it. Sorry about that, Shaw. There we go. Did that work?
Yep, I got it this time. Yep. All right, got it.
Yeah. Speaking of virtual meetings, Internet Archive and the whole DWeb community will be hosting DWeb Camp again this year. So if anyone wants to travel to, some visitor folks perhaps can go there, and I think there will be some opportunity to get funding from this the project that Michael, you and Kritika, we are working together on that one. Perhaps there will be an opportunity to get some travel funds from there and do that. It will likely be fun. I did not attend any of the camps that they had. I only attempted one of their more like the camps. They actually have like rent like an island or park or something, and you just go and have fun there. Like, I mean, it's like a big space that they hire open in the open, and you can have your own tents and whatnot, right? It's a different kind of experience, but that will happen in August. So plan accordingly.
Okay, excellent. Anything else? Any final words from anyone? I'd like to thank, let me see, we had 2 incoming students, Anton and David. I think David had to leave already, so we'll look for them in the fall. And of course, we had Friends of WSDL, so Danny, and we saw Vicky earlier. And I forget, I apologize if I missed someone, but I certainly appreciate everyone showing up. And we look forward to doing this again next year. All right. Thanks, everybody. Take care.
Bye.
Thanks,
Bye-bye.
bye.
Thank you all. Bye.
Thanks. Bye.